Okay, so buenos dias, good morning. Thank you for being here. I'm very honored to be participating in PyCaribbean. So let's get started. So whether you're learning or teaching Python, you'll eventually want to end up installing third-party packages. So enter easy install. Wait, not easy install, I meant pip. Enter pip. So let's imagine that in 2015, you start working on a project and you decide to use the best tool for the job. So you use Django 1.8. So you do pip install Django 1.8. And you just install Django globally. So sometime after, you decide to start working on your project and you go again for the best tool for the job. You use Django, this time 1.10. So you do pip install Django 1.10. And you just install Django globally. And that project you worked back in 2015, well, it happened to depend on some features that are now deprecated in 1.10. So you might be surprised when you go back and see some unexpected errors. So I want to talk to you about developer ergonomics, but specifically around package managers and environments. My name is Jose Padilla, as you already know. I'm Puerto Rican, and like 8 months ago, I moved with my wife and my dog to Hartford, Connecticut. For work, I do a couple of things. At Blimp, we do software development and consulting for other companies and digital agencies. At File Previews, we provide an API that produces image previews and extracts useful data from any file. And at Alias Payments, we build products like Gasolina Móvil, which is an easy, fast, and safe way to pay for gas using your phone. I also enjoy enabling, teaching, and helping others write software. I've helped organize various meetups, private trainings, and events like Building for the Web. For most of these, my go-to language has been Python, because it's concise, it has a clean syntax that leads to great readability. And it has a great standard library and ecosystem. Now, open source and community is definitely part of my DNA. I enjoy contributing back to any open source community, and I'm currently one of the maintainers for Django REST framework. I also maintain a Python JSON Web Tokens implementation called PyJWT, and I built Juicebox, which is an open source virtual machine designed for programming workshops. Oh, yes, and thanks Tracy for giving me awesome feedback on that. So a little backstory on this keynote. So in 2016, I spent a lot of time building services using Node and Ember instead of Python, like I usually did. I also worked on tons of consulting projects using Ruby and Rails, using PHP and Laravel, using C# and .NET. And after spending, a considerable amount of time using other languages other than Python, I noticed that there were some things that the Python ecosystem community could benefit from doing differently. So working with Node and NPM got me thinking about the ecosystem, about the ergonomics using Python and pip. So this talk is just a dive into the current behavior of both and my honest opinions on how we could do probably better. So let's begin. First up, Node and NPM. So NPM is Node's package manager. And installing packages with NPM is easy. We can do npm install express, which will install the express package, around 26 direct dependencies, and around 16 indirect dependencies. We can also do pip npm install express --save, which will install the express package, its dependencies, and it will add it to the package.json. So the package.json is just a file that is used by the npm client to identify the project as well as handle its dependencies. Note that we install express, and doing npm install express installs express and installs all of its dependencies. Our package.json only has our express package. We can install, and we can also uninstall packages with npm. So we can do npm uninstall express --save, which will obviously uninstall the package and its dependencies, and update the package.json, which will now look like this. So the default behavior of NPM is to install packages locally to the current working directory. So why would we want to install packages globally? Well, the most common use case is to install CLI tools like linters or test runners. And with NPM, we can do so by doing npm install ESLint -- global, which will install a package globally, and it will also make any executable binaries available to your path. Now, in most projects, you'll have dependencies that are only useful during development or testing phase of your application. And with NPM, we can handle that as well. We can do npm install supertest --save -dev, which will install our package, its dependencies, and it'll add the package to our dev dependencies in our package.json, which will look something like this. Now, we can also do npm install, which will install the packages under our dependencies key and under our dev dependencies key. We can also do npm install -- production, which you might have guessed it, just installs the packages under our dependencies key. Now, another thing npm handles pretty well is dependency conflicts. Let's say we install a package, in this case package A, and package A has a requirement of request 1.0. We install package B, which depends on request 2.0. Now, if we were to view our dependency tree, it will look something like this. We have our package A with its dependency of request 1.0. We have a package B with its dependency of request version 2. Now, packages and dependencies are sandboxed. So we're able to have each version of request under each package. So we avoid conflicts at that level. Now, let's talk about determinism. In Node and NPM, a deterministic installation just means that a computer with the same package.json will have the exact same source tree dependencies installed. Now, determinism is actually desirable. It helps you avoid the whole, it worked on my machine, but it broke when we deployed, or it doesn't work on your computer. But NPM doesn't actually install dependencies in a deterministic way by default. NPM does actually provide a feature called shrink wrap that allows for deterministic installs using a log file. Now, the npm shrink wrap.json file might look like this. It has our package, in this case it's called A, and it has its dependencies, and it has the exact version that we installed. Now, there are a couple of issues or caveats that with shrink wrap, right? So developers have to actually manually run npm shrink wrap to generate the log file anytime a dependency changes. It also doesn't verify the contents of each dependency, so we can't be 100% confident that we're installing the same dependencies and we can reproduce the exact same build every time. It also uses a JSON format, which might lead to readability issues when we're looking at diffs, which is basically the changes that are applied to the file. And now while we're talking about Node, let's talk about Node and Yarn. So Yarn is a fast, reliable, and secure alternative for the NPM client. It's fast because it caches packages, it downloads, and it parallelizes operations. It's reliable because it has a detailed but concise log file format, and it uses a deterministic algorithm for its installs. It's secure because it uses a checksum to verify the integrity of each package in your dependency tree. Installing packages with Yarn is pretty easy. We can do Yarn, which is sort of the equivalent to doing npm install, but this will also generate a log file for you called yarn.log within the root directory of your package next to your package.json. We also have yarn add express, which is sort of the equivalent to doing npm install express --save. This will also update or generate a log file. We also can do yarn add --dev mocha, which is sort of the equivalent to doing npm install mocha --save -dev. This will obviously save our package and will update our log file. We can do yarn global add ESLint, which is sort of the equivalent to doing npm install ESLint --global. Now, in order to get a consistent install across machines, Yarn needs more information than the dependencies you provide on your package.json. So it stores exactly which version of each dependency they're installed using the log file. So it looks something like this. The yarn. So a note. So the yarn.log file is actually maintained by Yarn, and you should not have to manually edit it at all. And something to note is that this is not JSON. This is some other kind of format. And after each resolved URL, you'll see a checksum. And that checksum is used to verify the integrity of each package you install. Now, let's stop talking about Node, and let's talk about Rust and Cargo. Cargo is a package manager for Rust, sorry. And it improved many of the great ideas of Node's NPM and Ruby's bundler. These ideas returned to help improve the JavaScript ecosystem with Yarn. So cross-pollination at its best. Now, Cargo has a file called the cargo.toml. This file is just like the package.json. It's about just describing the dependencies in a broad sense and is written by the developer. It is similar to the NPM's package.json, but it uses an toml syntax instead of JSON. Cargo also have a cargo.log, which is similar to Yarn's .log file. Now, the cargo log contains the exact version of each dependency, and just like yarn.log, is maintained by Cargo and should not be manually edited by the developer. Finally, we've seen how other package managers work. So now let's see how our Python's pip worked. So pip is the Python packaging authority recommended tool for installing Python packages. Installing packages with pip is easy. We can do pip install Flask, and that will install Flask and around 5 of its dependencies. Then we can do pip install Flask. We can do pip freeze, and pipe that to a file called requirements.txt. And this will install Flask, its dependencies. It will also add the dependency to our requirements.txt file. This is sort of the equivalent to doing yarn add. If we look at our requirements.txt file, you'll notice that there are way more packages than we actually installed. We have Flask, but then we have Click, It's Dangerous, GG2, Markup Safe, Workshoot. We actually didn't, I didn't mean to install any of these packages. I just wanted to install Flask. So that's something to keep in mind. We can install, and then we can uninstall packages. So we can do pip install Flask. We can do pip freeze, pipe that to a requirements.txt file to update our requirements text. So Flask is no longer there. But the package's dependencies are. These dependencies could actually still be used by other packages or even your application. So if they're no longer in use, it is now up to the developer to actually keep track of. Now, a common pattern in Python projects is to maintain environment-specific requirements.txt files. So a common setup that I've used and I've seen before is something like this. We have a root level requirements.txt file. Then we have a folder with our development-specific or environment-specific requirements. If we look into our requirements.txt file, it just has one line. It has -r requirements/prod.txt. This means that this file is actually requiring the requirements in that file, /prod.txt. If we then look at that file, we'll notice that it has something similar, -r common.txt, and it has 2 other dependencies. These are our production-specific requirements. If we then look at our common.txt file, we'll see that we have Django 1.10, 1.5, so that's our common dependency. If we then look at our def.txt file, we have one development-specific requirement, which is PyTest. Now, if we do pip install -r requirements.txt, we will install the requirements in our prod.txt file, and that file will also install the requirement in our common.txt file. But if we wanted to install our development-specific environment while testing or while development, we could then do pip install -r requirement/devtext. This will obviously install just our PyTest requirement that our file had. The default behavior, as we've already seen for pip, is to install packages globally. But what if we wanted to isolate our application-specific dependencies from our shared Python installation? Well, in Python 2, we have virtualenv. And virtualenv is a third-party library, which means you can install with pip. And virtualenv needs to be installed separately and globally, but it supports Python 2.6 and up and Python 3.3 and up. It installs pip, set of tools, and wheel in every created virtual environment by default. So now let's see how we use virtualenv. We can install with pip install virtualenv, and then after installing it, we can create an actual virtual environment. Now, we do virtualenv.venv. So this actually creates a virtual environment called .venv, which is kind of weird, but it happens that .venv is actually the name of the virtual environment and its folder. So it'll end up in a folder called .venv, and by default, this is usually a hidden folder. So my suggestion is usually to create it in your root of your project. That way, it's kind of easier to handle it. And after creating a virtual environment, you'll usually want to end up activating it. This changes the path environment variables so that the first entry is the virtualenv bin directory. Now, doing this is just purely convenience, and we'll see why. If you directly run a script inside the virtual environment's bin directory, like the Python interpreter, there's no need for activation. So in this case, we ran .venv/bin/python, and we're right there in the Python interpreter. If we do activate the virtual environment, your shell prompt will automatically change and will be modified to indicate that you're in a currently activated environment. If at this point we check which is the path to our Python executable, we'll notice that I'll be referencing the Python binary inside our virtualenv and not our system-wide Python installation. Okay, so finally, now we're inside our virtualenv, we can do pip install Flask, and this will install Flask and all of its dependencies, but inside our virtual environment. And just like we can activate, we can also deactivate. Deactivate just undoes the changes made to your path and your prompt. That's it. If at that point we do which Python again, we'll notice something similar to this. This is our system-wide Python installation, not the one in our virtualenv. So in Python 3, we have venv. So venv is actually available in Python.3 and later, and similar to the virtualenv, it installs pip and setup tools into the created virtual environment for you. Its implementation was based heavily on virtualenv, but they're not entirely identical. So this actually reflects in the usage of it. So to create a virtual environment, we do Python 3 -m venv and the name or directory for your virtual environment. So in this case, it's kind of weird because they happen to be really similar. So we might change that to something else later. Let's stick with .venv. After creating your virtual environment, you can also activate it, just like with virtualenv. Once in an activated virtual environment, we can run pip install like we usually do. This will install Flask, all of its dependencies, and inside the virtual environment. We can also deactivate to undo the changes to our path and prompt. Now, let's see how pip actually manages dependency conflicts. Let's imagine we have a package A that depends on request version 1.0. And we have a package B, which depends on request 2.12.4. If we run pip install package A, and then we run pip install package B, and then when we run pip freeze, we'll see something like this. We install our package A, we install our package B, but the install request version is actually 2.12.4. So package A might fail now because there could be some breaking changes in the request 2.12.4. This means that packages and dependencies are flat, right? Pip doesn't actually have a dependency resolver like npm or yarn does. But as of version 9.0 of pip, a check command was introduced. And if we run a check, like if we run pip check in our previous example, we'll see something like this. Package A has requirements request 1.0, but you have request 2.12.4. So now we know that there might be some issues in our installation. So the only downside with this is that you have to run this manually. But I think it might actually be useful if at some point we could run it automatically after doing pip install. As of right now, I just find the information is really valuable, but it might be too passive. This should raise an alarm, and it should make you aware that there might actually be something wrong in your installation. For now, maybe we can just run something like this: pip install Flask and pip check, which will install Flask, and after installing Flask, it will also run pip check just to make sure that our dependencies are all satisfied. We could also do like a simple bash function that does this for us. So if we did something like this, we'd be able to run pip install Flask, which will install Flask, and run pip check just afterwards. So going forward, I know that changing the defaults of tools like pip, which is used pretty much everywhere, without creating chaos is hard, or nearly impossible. But I have a feeling that installing packages in Python could be easier. And there's people that actually agree with me. Jamie Matthew from DabApps wrote a while back a blog post that's an intro to pip and virtualenv for Python beginners. And he quotes, "One of the hurdles that new Python developers have to get over is understanding the Python packaging ecosystem." And while we're at this, I was exchanging emails with Trey Hunter, who's a Python trainer and a director at the Python Software Foundation, and should be somewhere around here. Oh, there he is. And we were talking about his approach at teaching Python and how he explains pip. And he says something that I love. Variables in Python are local by default, so why aren't packages? You have to go out of your way to make a global variable. You should also have to go out of your way to install a package globally. I definitely agree with you, man. So, my ideal scenario. I wish that pip would default to installing packages locally instead of globally. I would definitely love an improved dependency resolving. Dependency hell in Python usually happens because pip does not have a dependency resolver, like we said, and because all dependencies are shared across a project. Now, some package managers like npm and yarn actually avoid this problem by making all dependencies dependency local instead of project local. Sorry. I also want it to be fully specified and deterministic, and I need it to be secure. So I imagine something like this. Running pip init would make sure that a virtual environment exists. It could also install virtualenv if needed, or fall back to using venv. We could run pip install Flask, which will install and save our requirement. This will also generate or update a log file for us. We could do pip install --dev to install a development-specific package. This will install it, save as a development requirement, and generate or update a log file for us. We could do pip install, which will install all of our requirements but using our log file. So the fun part, how does it actually work? Well, I didn't get that far, so honestly, I don't know. But on January 19, as I was scrolling my GitHub feed, thinking how I was actually going to build a proof of concept for you guys before this keynote, I noticed that Kenneth Wright, who you might know for his awesome contributions to Python ecosystem, open sourced pipenv. So let's talk about Python and pipenv. It was posted to Hacker News, and as far as I know, it lasted more than 15 hours on the front page, which just means that it got tons of attention pretty fast. As of a couple of days ago, it had more than 2,500 stars on GitHub, which just means it's kind of popular. And other libraries are already using it. Kenneth Wright's request package is already using pipenv. But what is pipenv? He describes it as the sacred marriage of pipfile, pib, and virtualenv. It is based on lessons learned from Composer, Cargo, Yarn, NPM, Bundler, and friends. It's cross-pollination at its best. So what's pipfile? In 2014, I saw that there was a GitHub ticket that was created to start defining what a requirements 2.0 might look like. And I noticed that in late 2016, the work on the pipfile spec implementation actually started. Pipfile will be superior to requirements.txt files in a number of ways. It will use the TOML syntax for declaring all types of Python dependencies, like our default dependencies, our development dependencies, our staging dependencies, our production dependencies. And we'll have one pip file as opposed to multiple requirements.txt files. Now, a pip file looks like this. Similar to our cargo.toml, similar to our package.json. We have our development-specific packages, and we have our default packages. In this case, it's PyTest and Flask. Now, the pipfile.log is just a log file that allows us to have a fully specified and deterministic environment. And similar to our yarn.log, similar to our cargo.log, and kind of similar to our npm trick wrap, we have a file that looks like this. We have all our default dependencies. We have our development dependencies, sorry. We have the specific version we installed, and then we have a hash. And that hash is for each packet that is added, so we can verify the integrity after installing. You can find more about the pip file and the pip file log implementation and what its spec looks like in its repo. And in my opinion, actually being under the Python Packaging Authority organization makes it more official. And I think it will be more likely that it will actually eventually be integrated with pip. So pipenv. It enables truly deterministic builds while easily specifying what you want. It automatically generates and checks file hashes for locked dependencies. It automatically finds your project home recursively by looking for a pip file. It automatically generates a pip file if one doesn't exist. It automatically generates a pipfile.log if it doesn't exist. And it automatically creates a virtualenv in a standard location, kind of similar to what we're doing with the .venv. It also automatically adds packages to a pip file when they're installed. It automatically removes packages from pip file when they're uninstalled. And as an added bonus, it can also automatically update pip for you. And guess what? Installing packages with pipenv is easy. We can do pipenv install Flask, which will install our package, and it'll add them for us to our pip file. it will also automatically generate our log file for us. We can install a development-specific dependency doing pipenv install pytest-dev, which will install our package and also add it to our pip file under the dev packages key, and it will also update our log file. If we run pipenv install, we'll install all of our packages using our log file. So we're sure that we're always building the same dependency tree, and we'll be able to have reproducible builds. There's something also called pipenv shell. This spawns a shell within the virtual environment. This is sort of similar to activating the environment when you're using something like virtualenv or venv. Now, there's only one drawback that I noticed, and this is only my opinion. So the log file is not automatically generated after every install. And after seeing people have issues with npm string wrap for just about that same reason, this usually leads or could lead to a stale pipfile.log. And after discussing a bit with some of the maintainers, one of the reasons was that currently locking is rather expensive time-wise operation. But that doesn't mean it has to be that bad, right? So we can do pipenv install flask, which will install our flask dependency. It'll also add them to a pip file, and it'll also update our log file. Oh wait, sorry. And then we can do pipenv log, which actually generates and updates our pipfile.log. There's also a one-liner, which I like. We can do pipenv install --log flask. This will install the package, update the pip file, and generate or update our log file. I urge you to check it out and give it a try. I would love to know how it works out for you, and even though I'm not actually maintaining it, I'm subscribed to it, and I'm looking forward to contributing as much as I can, and I would love to see this move forward. So definitely report any issues or feedback that you might have. So wrapping up, I think the takeaway for this is that it is our job to build the best software possible using the best tools for it. We, as developers, go out there to other communities and ecosystems, and we learn from others to make ours better. We have to remind ourselves that Python is not only for those that have been using it for the past 10 years, it's also for those that will begin using it for the next 10. I'm very thankful that there are smart people already working on how to improve this. And we have to remember that there's awesome work already being done, not only with pipenv, but with other alternatives. Pip, on the other hand, has so many contributors, and we've made so much progress. We've had the pip check command, we've had hash checking mode, we've had wheels, we've had caching, and all of that makes our lives as developers better. So thank you to everyone helping make Python and its ecosystem and community better. From the son of Python, beautiful is better than ugly, simple is better than complex. There should be one, and preferably only one, obvious way to do it. And now is better than never. Thank you.